Hello, my name is Amie Shuttleworth. I'm from the Department of Engineering. Today I'm going to introduce to you my PhD topic. I'm investigating how the building sector can create a meaningful balance between climate mitigation and climate change adaptation. Put simply, net zero adaptation. So although I'm in the early stages of my PhD research, I thought today would be a great opportunity to share my assessment of the current state of play of the built environment sector in relation to net zero carbon and climate adaptation, as I see this as an important network going forward, and also because there may be aligned research being conducted in other departments. So I hope that my thinking will resonate with some of the other work that you're doing, and if it does, please do get in contact. So just to put a bit of context to the research topic, the design, construction and operation of the built environment contribution to anthropogenic climate change is very significant. It's almost 40% of greenhouse gas emissions that are emitted annually are from this sector. So in response to this significant contribution, there has been a plethora of frameworks released in recent years to guide net zero carbon design and construction for buildings globally. And they're really aimed at developers, engineers, architects and contractors, all with slightly different scopes in terms of carbon inclusion and exclusion. And what I mean by that, for example, is that the World Green Building Council, their guidelines for a net zero carbon building is all the carbon emitted during the operation of a building, so from the lighting, heating, cooling, etc. But for the Better Building Partnership, they include the operational scope, but they will also ask you to include all of the carbon emissions associated with the extraction and manufacture of materials that go into a building. So although there are some alignment issues, there is quite a strong shift in the industry looking at climate mitigation, in particular trying to get to what they call net zero carbon at that asset and also portfolio level. However, as this graph shows, even if we do meet our net zero carbon targets, we will still need to adapt to climate change, as we're expecting around a 2-degree rise by 2080, well within the design life of buildings that are being designed and then constructed today. Building codes and sustainability assessment tools actually use past weather data, not future weather data in most cases, which means that buildings are actually not adequately designed for this future climate change. And therefore, there really needs to be a holistic approach, looking at both whole life net zero carbon, but also climate change resilient buildings. We really shouldn't be doing one without the other. So it's important to understand and articulate the impacts of climate change so that we can actually adequately prepare. We've already seen, I'm sure many of you have seen, sorry, that the impacts of climate change in recent years are already being felt. Where I grew up in Hong Kong, we've had more and more severe typhoons that have destroyed whole cities. I'm sure many of you have seen it or may even experience the devastating fires in Australia that not only impacted people, but also killed 6 billion animals. And this week even, we've seen severe winter conditions in the southern states of America, bringing the whole state of Texas to a standstill, causing huge disruption and damage. When it comes to the built environment, and looking specifically at adaptation, there is actually a lack of appropriate frameworks or metrics available for guiding or measuring climate adaptation at the building level. As we saw, there was quite a few for net zero carbon. And then just repeating what I said earlier, that compounding that issue, many design standards actually aren't deemed appropriate because they're based on historical climatic trends. So there's a bit of a systemic problem that we're seeing here. Now, there has been some research into the impacts of future climate change on buildings, and these include that there will be multitude of impacts, as you can imagine, such as locking in future retrofit costs into the current building stock, because as assets will not be able to operate in such a comfortable, efficient, or even safe manner throughout their design lifespan, they will have to be upgraded. So both academia and industry have very much concentrated on mitigation. However, we are starting to see that there is a realization that this balance needs adjusting. And then when trying to understand why mitigation has received so much more attention, some researchers have concluded that it's because climate mitigation targets for the UK, that's net zero by 2050, are just a lot clearer and easier to understand, whereas adaptation is actually a less tangible goal. Others have argued it's because there's no comprehensive tool that has been developed for the assessment of urban adaptation and resilience. And that really, to be integrated into the engineering and construction industry, it has to be codified so that it can be operationalized into design, which sustainability has been through other tools such as LEED, an American design tool. So in order to dig into this further, I conducted a review of 3 geographically diverse sustainability assessment tools, BREEAM from the UK, Green Star from Australia, and LEED from the US, which are created to codify sustainability into design and construction, because I wanted to better understand how and if mitigation adaptation is included with them. All of these tools have actually been updated since 2019, and the aspiration is to make them more holistic. So they should be including the mitigation adaptation that we've been discussing. So really we can say that these tools are a proxy for what is deemed best practice within industry at the moment. The results of my review demonstrate that although these assessment methods were updated very recently, and most buildings won't actually have been built using them yet, they're probably just using them for design, emphasis really is still on action pertaining to climate issues weighted towards mitigation. Very little integration of adaptation considerations. BREEAM, as you can probably see here, has the most obvious integration. And when you look into the technical details, you can see that this is quite holistic because it's demonstrated through inclusion of adaptation aspects such as water consumption, low carbon design, as well as the impacts of refrigerants. However, for that assessment tool, it's still not mandatory to complete a climate change impacts risk assessment, which makes it really challenging if you're an investor or developer, if you want to know whether climate risks have actually been assessed and even acted upon within the building that you want to buy or move into, even if it achieves the highest sustainability rating. So in summary, although net zero carbon has dominated the academic, political, and industry rhetoric in recent years, there is this increasing understanding that we must concurrently adapt to changing weather patterns. However, if codification of adaptation is required for it to be operationalized within the engineering and construction industry, as we've seen net zero carbon has, the analysis that I've conducted has demonstrated there's still some way to go for this to be integrated into assessment tools, which some academics have recommended is the best route. So the next steps of my project are to actually conduct socio-technical systems analysis, and that's going to be into the governance and decision making within the built environment sector to really understand how elements of that system influence the final design, construction, and management outcome of a building. And that's very obviously very much in relation to that balance of mitigation and adaptation. So if any of this is in line with the research that you're conducting, I'd really like to connect with you, and maybe we could collaborate. So thank you very much for your time today.